Hello everyone, this project is on Analyze Missing Values, which was done under the guidance of Dr. Farooq Alimi. The team members who worked on the project are Sri Lakshmi Durga, Nitya, and Mansa Pen Metsa.
In our class, we are working on 5 impactful projects that leverage AI and data-driven techniques to address challenges in healthcare. Each project focuses on a unique area, pushing the boundaries of what technology can achieve in improving patient care. Our group is specifically working on analyzing missing values project. We are addressing the challenges posed by incomplete dataset in clinical settings, particularly in the context of antidepressant treatment. By focusing on how missing values data squeeze predictive models, we aim to improve the reliability of AI-driven decisions, ultimately supporting more accurate and personalized treatment recommendations. Depression is highlighted as a significant global mental health issue and a leading cause of disability, affecting millions of individuals worldwide. Treatment challenge centers on difficulty healthcare providers face in selecting the most effective antidepressant, often resulting in a trial and error approach. The focus of the study is on evaluating predictive models for the antidepressant sertraline, aiming to understand its treatment outcomes. The ultimate goal is to enhance data-driven personalized care for managing depression and reducing the reliance on trial and error methodologies. Methodology. Data source. The project uses data from all of us research program, a diverse and longitudinal health dataset, providing a rich source for analysis. Eligibility criteria. The study focuses on patients diagnosed with major depressive disorder, explicitly excluding cases of bipolar disorder to avoid confounding results. Key steps: data preparation, cleaning and organizing the dataset for analysis. Feature selection, identifying significant predictors using methods like raster regression to improve model performance. Predictive modeling, developing models to predict treatment outcomes for sertraline. Model evaluation, the performance of predictive models is assessed using McFadden's R-square ratio to ensure the explanatory power of model, cross-validation to ensure robustness and generalizability of the findings.
The study includes a total of 53,421 participants from the dataset, ensuring a broad and diverse base for analysis. A specific set of individuals diagnosed with major depressive disorder was selected for focused analysis, as the study aims to evaluate antidepressant effectiveness in managing this condition. Participants diagnosed with bipolar disorder were excluded from the analysis. This was done to avoid confounding results, as bipolar disorder involves distinct treatment protocols and symptoms that differ significantly from major depressive disorder. The exclusion ensures the analysis remains specific for major depressive disorder and antidepressant treatment outcomes. Procedure overflow. Data is retrieved from the All of Us electronic health record database. It includes participants with at least one documented antidepressant prescription or diagnosis of major depressive disorder. Exclude patients with bipolar disorder. And then we are creating a consolidated grouping file for focused analysis on specific antidepressants, and then combine patient demographics, clinical measures, and adherence information into a unified dataset. Construct analysis data frame by organizing variables like age at antidepressant initiation, prior medication usage, and comorbidities. Feature engineering: enhance the dataset by creating dummy variables for categorical data, generating age group classification for subgroup analysis. Feature selection: applying lasso regression to identify the most significant predictors for remission outcomes, and run logistic regression, build predictive models to estimate the likelihood of achieving remission. The model evaluation is done by McFadden R-square, which measures the explanatory power of the model, and then cross-validation. It validates model's robustness and reduces overfitting. This stepwise process ensures thorough data preparation, modeling, and evaluation to predict antidepressants' efficacy effectively. From the antidepressant users, 21,332 participants were specifically prescribed sertraline. This subgroup was analyzed in depth to assess sertraline efficacy in achieving remission, defined as a significant reduction or elimination of depressive symptoms. Of those taking sertraline, 9,657 participants, that is 45%, achieved remission. The remission rate reflects sertraline's moderate effectiveness in treating major depressive disorder within the study cohort. The 45% remission rate underscores that while sertraline is effective for a significant portion of patients, there remains a considerable percentage for whom the medication may not work effectively or who may require alternative treatments. The AI model achieved a moderate accuracy of 63%, correctly predicting outcomes in most cases. Precision was balanced at 0.63 for both remission and non-remission, indicating that 63% of predictions for each class were accurate. However, recall showed disparity, with the model performing well in identifying non-remission cases, recall of 0.78, but struggling to correctly detect remission cases, recall of 0.45.
This slide shows the McFadden R-squared of 0.18, which indicates moderate explanatory power, capturing 8% of variance in the data. A minimal regularization parameter was applied to balance model complexity and prevent overfitting. While effective, these results suggest room for improvement through additional predictors and refined feature selection. Class 0, which is the non-remission class, shows strong performance with recall at 0.78 and F1 score at 0.70, indicating reliable identification. The remission class, which is class 1, struggles with lower recall value at 0.45 and F1 score of 0.53, which shows limitations in predicting remission. Precision consistency of both the classes shows equal precision at 0.63, reflecting balanced positive predictions. A total of 21,332 cases of sertraline use were analyzed, out of which 45% remission rate was observed. The predictive accuracy was 63%. McFadden R-squared value was 0.184. The findings highlight the moderate effectiveness of sertraline and the model's limitations. While the non-remission class showed strong performance, the remission class struggled due to potential class imbalance and limited feature delivery. The challenges with this model are it's better at identifying non-remission than the remission class. The predictive accuracy was constrained by a narrow feature set and missing data. The dataset's imbalance in remission and non-remission cases skewed results. The negative intercept suggested poor baseline calibration. To conclude, this study underscores the need for robust data handling techniques to improve antidepressant selection. Despite limitation, it lays a foundation for leveraging predictive models in mental health treatment by addressing critical issues like missing data and feature diversity. Future efforts should integrate comprehensive variables and refine model design for higher clinical impact.